Hey guys, so here's the notes for day 6. We're going to be solving exponential equations. Now there's going to be two different ways, okay? The first one is if we are able to get the bases on both sides of the exponential to be exactly the same, then we can use this property. So this says the property of equality for exponential equations. So if we have b to the x equals b to the y, meaning the bases on the exponential are exactly the same, then we can set the exponents equal to each other. So let's go look at example 1. We have 3 to the 3x minus 2 power equals 3 to the x plus 1. Notice that the base on both of the exponentials are exactly the same. So that means we can just set the exponents equal to each other. So I have 3x minus 2 equals x plus 1. I'm going to go ahead and solve for x. So I'm going to go ahead and subtract x from both sides. Got 2x minus 2 equals 1. Add 2, so I get 2x equals 3. And then divide both sides by that 2, so I get x equals 3 halves. Okay? Okay, let's go ahead. We're going to do the next problem. Now, just to kind of let you know, if you need to check your answer just to see if it works, or to make sure that is the correct answer, you can actually take the 3 halves and plug it back into x, and you should get a true statement when you evaluate. So there's a way that you can check to see if your answers are correct, okay? And we can do it here. Let's go ahead and might as well. You don't have to do this, but this is a way to check. So 3 to the 3 times 3 halves plus, 3 halves minus 2 equals 3 to the 3 halves plus 1. Okay. So we get 3, I get 9 halves here, so 9 halves minus 2. And I would say just use your calculator for that. We get 2.5, or 5 halves. And we do 3 halves plus 1, that also gives us 3 to the 5 halves. We can already kind of tell that this is going to work because our base and the exponent on both work, but we'll go ahead and figure all this out. So I do 3 to the 5 halves. And that's going to give us a decimal around 15.58. So we do get the correct answer here. So 3 halves is the right answer. So just letting you know, you can always check. Okay, now let's go ahead and look at B. We have 9 to the 2x equals 27 to the x minus 1. Now notice here the bases are not the same. We have to make sure the bases are the same so we can set the exponents equal. Now we have to kind of think, okay, is there exponentially wise a number that 9 and 27 can go into, okay? Or a number exponentially can go into 9 and 27. Well, we think it's going to be actually 3. Because let's think about that. 3 times what gives us 9? That is going to be 2. So I do have 2 times 2x here. Now notice the idea, and we've done this before, is what we call manipulating with our algebra, or rewriting. So 9 is the same thing as saying 3 halves, okay? I'm just rewriting. What about 27? Well, actually, 3 to the 3rd power, that's another way to rewrite 27. Now, don't forget, we need to keep what is already in the exponent. Now, because our bases are exactly the same, we can go ahead and set our exponents equal to each other. Now, I do have to multiply, so I do 2 times 2x to give me 4x. And I do need to distribute the 3, so I get 3x minus 3. Now I just solve, I'm going to subtract 3x from both sides, so I get x equals negative 3. Okay. Okay, let's go ahead and do the last one. We have 4 to the x equals 1 half to the x minus 3. So we have to once again think about, what values exponentially can go into 4 and 1 half. Now, you can kind of change this quite a bit. There's actually a lot of different ways we can solve this, okay? We could make both bases be 4. We could make both bases be 1 half, or we could make both bases be 2. So it kind of just depends on what you would like to do, but we will get the same answer here, okay? So let's maybe think about, I like to keep it nice and full, but let's go ahead, we can do 1 half, right? So if I think about 1 half to the 4th power, right? Well, let's think about 2 to what power gives us 4? Well, that's 2, right? But if I'm going basically from a whole number to a fraction or vice versa, do I have a positive or negative exponent? That is going to be a negative exponent, okay? So this is going to be negative 2 to the x. And then my 1/2 stays exactly the same because I didn't change that base. Now, the bases are exactly the same. I just set the exponents equal to each other, so I have negative 2x equals x minus 3. I'm going to go ahead and just move the x over, so I get negative 3x equals negative 3. Divide both sides by that, and I get x equals 1, okay? Now, as I said, you could have done multiple ways. So here we could have done it with a 2. If that was the case, well, 2 to what power gives us 4? That's going to be a 2. And don't forget the x, because we do have 4 to the x there. And then 1/2, and we change that to a 2. Well, notice we go from a fraction to a whole number that makes it a negative, and 2 to what power gives us 2? That's going to be 1. So I do have negative 1, and this can be as x minus 1. Okay? So doing it this way, let's see. We should be able to get x equals 1 here. So I'm going to set these equal to each other, so I have negative x plus 1. I'm going to add here, make sure, there we go. So then from here, I think that should be x minus 3. That's why. Make sure you also write it correctly. Minus 3. There we go. Okay, so we have plus 3. Okay, now I add x to the other side. I get 3x equals 3. Divide both sides by 3, so I get x equals 1. Notice I get the same exact answer, okay? So sometimes there are going to be multiple ways that you can solve these problems, meaning you can rewrite them using different exponents, okay? Okay. Yeah, we'll go ahead, make sure you watch the next part of our day 6 note.